Welcome back to another video. In this video, we're going to talk about the fundamentals of probability, okay? So yes, we are beginning to talk about probability. So the probability, for a basic definition, is the extent to which something is probable. So basically, we take a number and we assign it to an event or a situation or something that we want to figure out how probable is that event, okay? So probability, or the number that we assign, is on a range from 0 to 1. If the probability is 0, that means it is very impossible for that thing to happen. So basically, what is the probability that cows will fly? The probability that is 0. It's like impossible for cows to fly, right? If the probability is 1, that means it is certain that that thing is going to happen. Okay, so what is the probability that you would die, that I would die, that everyone would die one day? The probability will be 1, because we all have to die one day. Okay, so if the probability is 0, it's impossible. If the probability is 1, it's certain that it's going to happen. Now, anything in between. So now if you're directly in the middle, 0.5, then we say, okay, it's a 50-50 chance of that happening, whatever that event is. If it's 0.5, that means it's 50-50 chance that that can happen. Anything between 0 and 0.5, we say is unlikely. And anything between 0.5 and 1 is likely. Okay? And so this is how the probability scale ranges. So anything between 0 and 0.5 is unlikely. Anything between 0.5 and 1 is likely. 0 is impossible. 0.5 is 50-50, and 1 is for certain it's going to happen. So now we're going to talk about the theoretical probability. And theoretical probability is basically the probability in theory. Like when you think about that thing, you know, what is the probability that it'll happen? So before we can talk about the theoretical probability, we have to define some basic terms. And so we're going to define, first of all, a sample space. Sample space is the set of all possible outcomes, and we usually use a capital S to denote the sample space. So whatever it is you're talking about, that's the set of all the possible different outcomes. And I'll give you some examples in a minute. An event is any subset of the sample space. So an event is usually what we're interested in. And so if our event has an equally likely number of outcomes, if the outcomes are equally likely, and if our sample space has equally likely outcomes, then we can find the theoretical probability. And the theoretical probability, which we will call P of E, that's the probability of an event, is found by taking the number of the events, which we use N of E to describe. That's the number of the event, the thing that we're interested in, divided by the number in the sample space. And that's the number of all possible outcomes. Okay, so just for a basic, simple example, if I wanted to find the probability of flipping a head, getting a head when I flip a coin, okay? So when I flip a coin, what are all the possible outcomes? So for my sample space, the only thing I could get is a tail or a head. So I only have 2 things in my sample space. Alrighty, so an event would be if I'm interested in one of those. So an event, which I call E, would be, let's say, tails. So what's the probability of flipping the tail? I may have said head earlier, but right now we're going to say, what's the probability of getting a tail when you flip a coin? Well, there's only one tail, so the number of the event is 1. There's only one tail, and then the number in the sample space is 2. So the probability is 1 over 2, which is 0.5, which on that scale earlier, we said if the probability is 0.5, then there's a 50-50 chance that that'll happen. So there's a 50-50 chance of me getting a tail if I flip a coin. Alrighty. So that's theoretical probability. You think about all the different possible outcomes you can have, and then you think about all the different ways you can get the thing that you're interested in. You take those numbers and divide them, and that will give you your probability. Let's look at some examples. Okay, for this first example, say you're rolling a dice. Alrighty, I have a dice in my hand. Now, on your standard dice, it's 6 sides. You can roll 1, you can roll 2, you can roll 3, you can roll a 4, you can roll a 5, or you can roll a 6, okay? So if I want to find the probability of anything dealing with rolling a 6-sided dice, my sample space is going to include the numbers. So I'm going to write it out in set notation. This is a brace, which is how you represent a set. And I'm going to list all of my possible outcomes. I can get a 1, a 2, a 3, a 4, a 5, or a 6. And so that's what my sample space will look like. That's all the possible outcomes of rolling this one dice, okay? So now I want to find the probability of a few things. The first thing I want to find the probability of is rolling a 3, okay? So now for part A, my event is equal to a 3, rolling a 3. Well, what is the number of times I can get a 3? So that's what N of E would be. So N of E would be, there's only one 3 in that sample space, so N of E will be 3. Now what I didn't talk about is the number in the sample space, which we'll call N of S. The number in the sample space here would be 6, because there are 6 things in the sample space, so N of S is 6. So now if I want to find the probability of E, where E is 3, then that will be equal to the number in E over the number in S, or the number of S. So in this case, the number of E is 1, the number of S is 6. So the probability will be 1 over 6. That will be the probability of rolling a 3, okay? Next thing I want to do is I want to find the probability of rolling an even number. So in this case, my E represents even numbers. All right, well, N of E is going to be how many even numbers are in my sample space. Well, 2 is an even number, 4 is an even number, and 6 is an even number. So that's an even number. I'm going to put a box around them so you can see. So I have 1, 2, 3 even numbers. So my N of E, which would be the number of even numbers, would be 3. So now when I go to find the probability of E, it will be equal to the number of E over the number of S, which is the sample space. The number in E is 3. The number in the sample space is 6. 3 over 6 can actually be reduced. 3 go into both of those numbers, so you can divide the top and bottom by 3. And that reduces down to 1/2, which is 0.5, which again fits right in the middle of my probability range, which means there's a 50-50 chance that you'll roll an even number. Now for the last part, part C, our event is a number greater than 6. So now to find N of E, we will look at our sample space and see how many of these numbers are bigger than 6. And as you can see, none of these numbers are bigger than 6. So N of E is equal to 0. So the probability of E will be N of E over S of E. Not S of E, N of S. Hopefully I didn't write S of E in the last one. But it's supposed to be the number of the event over the number of the sample space. And so the number of E is 0. The number in the sample space is 6. 0 divided by any number is 0. That means the probability of rolling a number greater than 6 is very impossible if you're rolling this dice, because there are no numbers on here greater than 6, okay? So our probability of this event will be 0. And so that's how you would find the theoretical probability of those events. And you can find different events when it comes to rolling a dice. I could have said, what's the probability of rolling a 1? What's the probability of rolling an odd number? What's the probability of rolling a number less than 3? So there are so many different events you could be interested in, but the way you will find is by taking the number that the number of times the event can occur divided by the number in the sample space, which is the number of all the possible outcomes. Let's look at another example. Okay, for example 2, we're going to be looking at a standard deck of cards. Now, if you're familiar with the deck of cards, then it comes with what we call 4 suits, hearts, diamonds, spades, and clubs. And then each suit comes with an ace, numbers 2 through 10, a jack, a queen, and a king. Okay, so I'm going to put up a picture of a standard deck of cards. I'll allow you to look at it. You can pause the video for as long as you need if you're not familiar with the standard deck of cards, and look at it and study it and see what all comes in a standard deck of cards. So now that you familiarize yourself with the standard deck of cards, There are 13 cards in each suit. There are 4 suits, so that means there are a total of 52 cards in a standard deck, not including the jokers. Okay, so if you play spades, if you're a spades player, then the jokers are really, really important. And so that deck of cards would be 54, but we're talking about the standard deck without the jokers. Okay, so 52 cards in the deck. So now suppose that you are dealt 1 card from a standard 52 card deck, and you want to find the probability of each. So we're going to find the probability of 3 different things. And first thing we're going to do is find the probability of being dealt a king, okay? So our event here, so remember our sample space is all of the different possible outcomes you can get. However, I'm not going to list all 52 out. That would be all the outcomes you just looked at of the cards, the whole layout of the cards. But the number of the sample space is equal to 52, okay? Now for part A, our event is a king. So basically what we want to do is count how many kings are in the deck. So now you could get a king of heart, a king of diamond, a king of spade, or a king of club. There's a king in every suit. So that means there are 4 kings, okay? So the probability of getting a king, where our event is king, will be the number of ways you can get a king over the number in the sample space. So that will be 4 over 52. And then you will reduce it if you can. Actually, you can. 4 goes into the numerator and the denominator. 4 divided by 4 is 1. 52 divided by 4 is 13. So the probability would be 1 over 13. Now we want to find the probability of getting a heart. So this time our E would be heart. And if you go back and look at the standard deck of cards, remember there were 4 suits and there were 13 cards in each suit. There was an ace, 9 through 10, and then a jack, queen, and the king. So there's 13 cards in each suit. So that means there's 13 hearts. So the number of E will be equal to 13. So now if I want to find the probability of E, where E represents heart, it will be the number of E over the number in the sample space, which will be 13 over 52. And then you reduce it if you can. 13 actually goes into the top and bottom, so I'll divide both by 13, and that reduces down to 1 out of 4. So the probability of getting the hearts is 1 over 4, which is 0.25, which is a really small. It's in that unlikely category, but it doesn't mean that it won't happen. It's just not a really big chance that it will happen, that you'll get a heart, okay? Now for the last part, we want to find the probability of getting a king of hearts. So in this case, my E would be a king of hearts. And so now I need to consider how many times can I get a king of hearts? Well, remember there is a king for every suit, but a king of hearts means there's only one there's only one king in the heart suit. So there's only one way I can get a king of hearts. So that means the probability of getting a king of hearts will be equal to, again, the number of the event over the number in the sample space, which will be 1 over 52, and that cannot be reduced. And if you divide that, that's a really small number, which means the chances of getting a king of hearts is almost impossible. But it's not impossible because we know that there is one in there, but the chances of you getting it is really small. Alrighty, let's look at one more example. All right, for this next example, we want to take 1 dice, but we want to roll it twice, okay? And then we want to add each number that we get. And so there's a chart that I'm going to put up in just a moment. There's a chart that you can look at that shows you all the different possible outcomes that you can get if you roll either 2 dice. You can say you can use this chart for 2 dice also, or if you take 1 dice and roll it twice, okay? And it gives you every possible outcome. Like if you get a 1 the first time and a 1 the second time. If you get a 1 the first time, a 2 the second time, a 1 the first time, a 3 the second time, 1 the first time, a 4 the second time, and so forth. So if you do that, you can get, there are 6 possible outcomes you can get for the first one, and there are 6 possible outcomes you can get when you roll it the second time. So if we use our fundamental counting principle, that means there are 36 possible outcomes of what you can get when you roll 2 dice. Because you have 6 times 6, which is 36, okay? So there are 36 possible outcomes. So what we want to do is we want to find the probability. Let me see what we want to find, the probability that the sum of the two numbers is 6. So now we could look in that chart, which I don't have it here. I showed it to you a while ago. But you can look in that chart and find all the different ways that you can get 6, okay? So first of all, I mentioned the number of possible outcomes because that will be the number in your sample space, which is 36. And we got the 36 from taking the 6 times 6. All right, so now the event is getting a sum of 6. So now we want to figure out how many ways can you get a sum of 6. So if you think about it, if you get 1 on the first row and 5 on the second row, that will get you a sum of 6. If you get 2 on the first row, 4 on the second row, you get 3 both times. Also, if you get 4 on the first row and 2 on the second row, which is different from 2 and 4 because 2 is on the first row here, 4 is on the first row here. And then if you get 5 on the first row and 1 on the second row. Now you can't get 0. So if you roll a 6, there's no way that you can get a sum of 6 if you roll the dice twice. So these are all the different ways you can get a sum of 6 if you roll this dice twice, which is 1, 2, 3, 4, 5 ways. And so that means that the probability of rolling a sum of 6 will be 5 out of 36. There's no number that goes into both of those, and so 5 over 36 would be your final answer, okay? And if you wanted to, you could actually divide out 5 over 36 to see what it is. And it's 0.13888, which is close to 0, which means it's in that unlikely category. Doesn't mean it won't happen. It's just a really small chance that it will happen, okay? And so that is the basic fundamentals of probability and theoretical probability. There's also another type of probability called experimental probability, which we're not going to talk about right now. But theoretical probability is when you actually think about the theory of what could happen. What are the possible outcomes that can happen, and what are all the ways you can get the thing that you're interested in, which is the event, okay? If you have any questions whatsoever, don't hesitate to ask them. Again, you can put them in the comments, or you can reach out to me personally. If you understood everything in this video, go on and hit that like button. And if not, then I will see you in the next video. And thanks for watching.